All right, so in your notes, please make sure that you have how to identify if it's a linear function. So you have if it's written y equals mx plus b form, and if it has an exponent of only 1 or 0. Okay, so if it's not a linear function, that means our exponents are not 0 or 1. And then also we notice that if the x, the variable, is in the denominator, it is not a linear function. So variable in the denominator. So in denominator. So these two things would make it so it's not a linear function. All right, next we're going to look at how to identify if a table is a linear function. So do the points on the graph in the table create a straight line? So what we need to look at is the rate of change. And if we recall from 4.02, rate of change is the change in y over the change in x. So change of y over change of x. If that rate of change is constant, which means it does not change, it stays the same thing, then we are working with a linear function. So I'm going to look at the table on my left and I'm going to say, okay, what is the change in y? So to get from 5 to 8, we add 3, 3 to 11. I add 3, 11 to 14 is add 3. My change in x, to get from 2 to 3, that's add 1, 3 to 4, add 1, 4 to 5, add 1. So my change in y over my change in x, that's 3 over 1. This is 3 over 1, and this is 3 over 1. They all simplify to the same thing. So my rate of change is 3. Because my rate of change is 3 throughout the whole thing, this is a linear function because my rate of change is constant. It remains the same. Now let's look at the table to the right. To get from negative 3 to 0, I would have to add 3. To get from 0 to 2, I would have to add 2. To get from 2 to 6, I'd have to add, not 2, that would be 4. Now my change in x, to get from 1 to 2, I would add 1 to get from 2 to 3, and to get from 3 to 4, I would add 1. So my rate of change, I have 3 over 1, I have 2 over 1, and 4 over 1. Well, 3 over 1 reduces to 3, 2 over 1 reduces to 2, 4 over 1 reduces to 4. Because the rate of change is not the same throughout the whole table, this is not a linear function. It is a function because we notice our inputs never repeat, but it is not a linear function. It will not create a straight line. All right, so lastly, we're going to look at another strategy on how to tell if a equation is a linear function. So if you see an equation, you're like, I'm not sure if this is written in y equals mx plus b form, or if my exponent would be 0 or 1. What you could do is you can create a table with the different values. So I'm going to go ahead and I'm going to say, okay, so I have an x and a y, and here's my table. You can pick any values you want for your x. I'm going to pick 1, 2, and 3. Again, you could pick any values you want to. So since my first value is x is 1, I'm going to take that 1 and I'm going to plug it into my equation. So I have y equals 3 times 1 times 1 minus 2. Notice my 1s are wherever my x's were because I'm no longer using x, I'm using 1. So 3x is really 3 times x, so that's why I have 3 times 1. So order of operations, we do x parentheses first. So I'm going to do what's in the parentheses first. So that's y equals 3 times 1 times 1 minus 2 is a negative 1. So now I could go ahead and multiply. So 3 times 1 is 3 times negative 1 would give me a negative 3. So that's a negative 3. Right? Now I have x's too, so I'm going to go ahead and where the x's are, I'm going to plug in 2. So that's going to be 3 times 2 times 2 minus 2. So that would give me 3 times 2 times 0. Remember, you have to do parentheses first. There's something to do in here, so I do that first. So 3 times 2 is 6, times 0 would give me 0. So this value is 0. And then lastly, we have 3. So I'm going to plug that in. I'm going to try and squeeze it over here. So that's 3 times 3, and then times 3 minus 2. So order of operations, do what's in the parentheses first. So 3 times 3 times 3 minus 2 is 1. So that would be 9 times 1, which would give me 9. All right, so now when we look at this table, we're going to say, does it have a constant rate of change? Well, to get from negative 3 to 0, I would have to add 3. To get from 0 to 9, I'd have to add 9. And to get from 1 to 2, I'd add 1. To get from 2 to 3, I'd add 1. So when I do my change of y over my change of x, I have 3 over 1, which reduces to 3. And I have 9 over 1, which reduces to 9. These are not the same, which means that this is not a linear function. Another way of looking at this is if you didn't want to make the table. What we notice in the equation is I have 3x on the outside and x minus 2 on the inside. If I were to distribute this in, that would produce y equals 3x squared minus 6x. And because this has an exponent of 2, that is not a linear function. Okay. This next one, I look at it, it's written in y equals mx plus b form, so this would be considered a linear function. But just for this sake, we can pretend that I didn't realize that, and then I could create a table. So my table, I'm going to put an x and a y, and again, I'm going to pick 1, 2, and 3, and I'm going to plug that in. So y equals 4, and it's no longer x. I'm putting in my 1. Minus 5. That gives me 4 minus 5, which is a negative 1. So that's negative 1. My next one would be y equals 4 times 2 minus 5. So that would be 8 minus 5, which would give me 3. So that's a 3. And my last one, when I plug in the 3, that would be y equals 4 times 3 minus 5. 4 times 3 is 12 minus 5, which gives me 7. All right, now let's look and see, does it have a constant rate of change? We'll get from negative 1 to 3, I would have to add 4. To get from 3 to 7, I'd have to add 4. To go from 1 to 2, I add 1. 2 to 3, add 1. So this is 4 over 1, and then 4 over 1. These both reduce to 4. So the rate of change is constant, which means this is a linear function.